Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Further Mathematics Paper 2, which is a Further Pure Mathematics 2 for May-June 2021, and the code is 9231/21. So for your information, this question paper is same as 9231/22, which is the variant 2. Okay, so let's move on to question number 1. Question number 1a. Given that a is an integer, show that this system of equations has a unique solution and interpret this situation geometrically. Okay, so now to show that the system of equations has a unique solution, we have to check the determinant. Alright, so now I will consider the determinant of the matrix. So take the coefficients for all the variables. So a 3 1, 2 1 3, okay, 2 here, 1 here, 3, then minus 1 2 negative 5. Now the determinants of this can be found by fixing one row. Okay, so I will fix first row and I will label the sign for all the elements here. So plus, minus, plus. After that, followed by considering the column. So when I consider the column 1, the cross out is A. Okay, so then from here I will get plus A, then determinant of the remaining terms. Then now, the next is to consider the second column. So when we consider second column, the determinant, the cross out is 3 and the sign is minus. So 3. Then the remaining terms, right, will be 2, 3, negative 1, negative 5. And then followed by considering third column right now. So the cross out is plus 1. Okay, with the coordinates, with the elements of 2, 1, minus 1, 2. Alright, so here I have reduced it to 2 by 2 determinant. Then here you can just use cross multiplication. So it is 1 times minus 5, I get minus 5. Then minus this multiplication, so minus 6, minus 3. And here you multiply, it is minus 10, minus another multiplication. That means this is minus 3. So plus 1, so 2 times 2 is 4. Then minus 1 times 1 is minus 1. Okay, so from here, I will get a times minus 11, negative 3 times, this is minus 10 plus 3 is minus 7. Then plus 1, 4 minus 1 is 5. Okay, so from here, at last, I will be getting minus 11a. This is plus 21 plus another 5, I get plus 26. Alright, so from here, we know that the a is an integer. So if the a is an integer, right, the determinant will not be 0. Given a is an integer, then the determinant will not be 0. Okay, so when the determinant is not 0, therefore, the system of equations has a unique solution. Okay, so done for the first part. We already shown it. And then interpret this situation geometrically. So it means that, right, so I will write here, interpretation. So when you're solving 3 equations, means that you are given 3 planes. Alright. So these 3 planes will be meeting at a single point. So you can still say 3 planes intersect at a single point. Because it has a unique solution, means that you will be able to get the exact value for x, y, and z. Alright. So that's the last part of this question. Now, part B, find the value of A for which x is 1, y is 4, z is minus 2 is the solution for the system of equations in part A. Okay, so means we need to find A given these three variables. So what we do is we will just refer to the first equation, right, and replace. So I will write from ax plus 3y plus z equals to 14. So now replace all these three values. Okay, x is 1, y is 4, z is minus 2. That means I'm getting a times 1 plus 3 times 4 plus minus 2 equals to 14. So here is a plus 12 minus 2 is 10. Therefore, my a is 4. Okay, done for the part B. Now for question 2. The variables x and y are related by the differential equation. A, find the general solution for y in terms of x. So now, this is second order differential equation. To solve this, we need to let right side be 0. Once you let right side be 0, we will be getting the auxiliary equation. Okay, factorize this into two linear factors, then you will be getting m plus 2 times m plus 1 equals to 0. Therefore, my m is going to be negative 2 and negative 1. Just let the factor be 0, right? So now my CF, complementary function, y is, since you are getting two different m values, it will be AE minus 2x plus BE minus x, because you are given dy dx. So your solution will be y in terms of x. Now, next is I let y be px plus q. This is my trial solution. So I get this based on the right side of equation 1. Okay, so now differentiate 2 times. dy dx is p. d squared y over dx squared, it will be 0. So I let this be second equation. Now I substitute second equation into first equation to get the p and q. So firstly, second derivative is 0. Then 3 times dy dx is p plus 2 times y is px plus q, then equals to 2x plus 1. So from here, I will compare, right? Before I compare, I will just group the x and the constant first. So here I do expansion, I get 2px, and then I will be getting 3p plus 2q, that equals to 2x plus 1. Then from here, I will just compare. 2p equals to 2, therefore the p is 1, and then 3p plus 2q is 1. Therefore, 2q is 1 minus 3, which is negative 2. At last, my q is negative 1. Okay, once I found this, then I will just write my pi, particular integral, y equals to px plus q. So the p is 1, so x minus 1. So after you have found this, right, I will just write my general solution, y equals to cf, complementary function plus particular integral, which is ae minus 2x plus be minus x plus with the x minus 1. So this is my general solution. And now when you look at the question, okay, just find general solution for y in terms of x, which means I have solved the problem. Right? So now B, state an approximate solution for large positive values of x. So large positive values of x means x tends to infinity. Okay, so now when x tends to infinity, I need to find out the values for exponential minus 2x and exponential minus x. So now exponential minus x is basically 1 over ex. So when the x is a huge number, ex becomes a huge number. So 1 divided by a huge number, it tends to 0. Same goes to e minus 2x. So it will tend to 0 as also. That means my y will tend to, okay, so when here is 0, this is 0, this is 0, that means my y will tend to x minus 1. Alright, so my y approximate to x minus 1. So that's the solution for part B. Okay, now for question number 3. The diagram shows the curve with equation y equals to x cubed. That means this is y equals to x cubed. The x is defined from 0 to 1. Here, 0 to 1. Together with the sets of n rectangles. So there will be n rectangles here with width 1 over n. So here is 1 over n. Alright. So now, A, by considering the sum of the areas of these rectangles, show that the integration is less than un, whereby the un is this. Alright, so now I will start with sum of areas of the rectangles. So now, when you look at the graph here, okay, so firstly, right, area of rectangle is base times height. Okay, so all the base will be same value, which is 1 over n. So I will write 1 over n times the height of the rectangle. So the first rectangle, right, for your information, first rectangle, and there are n rectangles here. So basically, first rectangle, okay, when you look at here, this is our first rectangle. So the height here is when the n is 1 over n, when the x is 1 over n. So now your y is x cubed. That means this is going to be 1 over n cubed. Okay, which means we are actually referring to the second ordinate. See here, second ordinates of the rectangle. Now for the second rectangle, I will refer to 2 over n for my x. So this is 2 over n cubed because x cubed. Okay, so from here until the last one, here last one, the n is, this is going to be 1 cube. Or you can say this is n over n, right? N over n cube. Okay, so remember we are referring to the second ordinate for the height. So here I will be getting 1 over n cube for the first rectangle. Second rectangle, 2 over n cube plus 3 over n cube plus until n over n cube. Okay, which is from the graph. Now, from here, you will notice that all the denominators will be n cube. Okay, after you bring in the power 3. So the n cube will be factorized out. So 1 over n times 1 over n cube. Then you will have 1 cube plus 2 cube plus 3 cube until n cube. Right? So this one no need bracket. So plus n cube. Now, this is 1 over n degree 4. This whole bracket will be summation r cube. R from 1 to n. So now I will use the formula from the formula list. Okay, so summation r cube, the r from 1 to n is basically 1 over 4 n squared multiplied with n plus 1 squared. So now I will replace accordingly. 1 over 4 n squared times n plus 1 squared. So now the n squared and n degree 4 can be simplified. So here becomes n squared. Right? Then I will be getting 1 over 4 n squared, the n plus 1 squared. But then when we look at the answer here, it's less than the un. Un is this, which is our sum of the areas of rectangles. So I need to take out the square. So which means this is 1 over 2n squared, then n plus 1 squared, which is also n plus 1 over 2n squared. Okay, so now from the graph, we know that area of the rectangles, right, when you get the total, it will be always greater than area under the curve. Okay, because of these extra parts, right? So area under the curve is basically integration from 0 to 1 for this graph. So now I will write here area under the curve equals to integrate 0 to 1 x cubed dx. So now area under the curve is less than sum of the areas of rectangles. Therefore, integrate from 0 to 1 x cubed dx, it will be less than n plus 1 over 2n squared. Okay, so I will say that integration of this function is less than un, whereby the un is n plus 1 over 2n squared. So this is how we prove the inequality. Okay, now B, use a similar method to find in terms of n a lower bound Ln for this. Okay, so now just now was upper bound basically. Okay, so for lower bound, now we have to refer to another rectangle. So remember just now we refer to the second ordinate of the rectangle. So now here we have to refer to the first ordinate. Okay, so first ordinate means for the first rectangle is basically here. So it means that it is 0, right? No area. Then the second rectangle is using this ordinate, which means now my rectangle is here, whereby this height is 1 over n. Okay? Right, so same for the last rectangle. I'm using this. So the height is going to be 1 over, n minus 1. So n minus 1 over n to the power of 3. Okay, this height is going to be 1 over n to the power of 3. Alright, so that's a difference now. So here, my Ln is 1 over n. The first height is 0 cube. Then 1 over n cube plus 2 over n cube plus until n minus 1 over n cube. Okay, so from here, the 0 cube, you can just ignore it. Then at the same time, I will factorize the n cube at the denominator. So it becomes n. Okay, I'll do it step by step. So n, then after that, n 1 over n cube. Then the 0 cube, just ignore it. 1 cube from the numerator. Then 2 cube plus until n minus 1 cube. Okay, so this is 1 over n degree 4 summation r cube, r from 1 until n minus 1. Because our last value now here is n minus 1. So use back the same formula just now. Summation r cube, r from 1 to n. It is 1 over 4 n bracket n square brackets n plus 1 squared. It's just that now your last value is n minus 1, which means you have to change this n to n minus 1. Okay, because I have changed this to n minus 1. So now here, I will be getting 1 over n degree 4, then the 1 over 4 from the formula, and then the n here change to n minus 1, and then you square it. And n plus 1, the n itself change to n minus 1, after that you plus 1. You square it. So from here, I will be getting 1 over 4n degree 4, n minus 1 squared. Then now for the second bracket, you see here minus 1 and plus 1 becomes 0. Basically just n squared. So again, now the n squared and n degree 4 can be simplified. This is 2. So I will be getting n minus 1 squared over 2n squared. Okay, and at last I will just combine the numerator and denominator by factorizing the squared. So then now integrate 0 to 1 x squared x cubed dx. Okay, so when you look at the graph right now, so you are just finding all this region. Okay, so obviously the sum of the areas of the rectangle is smaller than the actual area of the graph. So I will write the actual area of the graph is greater than Ln, whereby the Ln is n minus 1 over 2n squared. So this is the lower bound. Okay, now C, find the least value of n such that un minus Ln less than 10 power negative 3. So un minus Ln less than 10 power negative 3. The un is the upper bound from the first part. So the first part just now was n plus 1 over 2n squared. Minus the lower bound is this value or this expression. So n minus 1 over 2n squared less than 10 power negative 3. And now we need to find least value of n. So since both denominators will be 2n squared, square of 2n, then I will bring in the squared, it becomes 4n squared. Okay, and at the same time, this squared, I bring it into the numerator, then you have to do expansion. So it will be n squared plus 2n plus 1 according to the quadratic expansion. Okay, and then you minus square of n minus 1 is n squared minus 2n plus 1. And then less than 10 power negative 3. So the numerator, when you open the brackets, it will be n squared plus 2n plus 1 minus n squared plus 2n minus 1 over 4n squared less than 10 power negative 3. So from here, the n squared will be cancelled off, and then the 1 will be cancelled off. So I will get 4n for the numerator. So 4n over 4n squared less than 10 power negative 3. Then now the 4n will be cancelled off from numerator and denominator, but then I still have the n in the denominator. Right? So now the n move up. That means it will be n over here less than 10 power. This 10 power negative 3 you move down. So when you move down, it will be like this. Right? So I will read from the right side to left side. That means n is greater than 10 power 3. 10 power 3 is basically 1000. Alright, therefore my least n. So now my least n is 1001. So that's the solution of this question. Okay, now for question number 4. Find the solution of the differential equation. This is a first order differential equation where theta between 0 and pi, given that y equals to 1, theta equals to half pi. Give your answer in the form y equals to f theta. Now you may use without proof the result. Integrate cosec theta is ln tangent half theta. So now, since this is first order differential equation, to solve this differential equation, we need to apply the integrating factor. So now for integrating factor, make sure the coefficient for dy dx is 1. Therefore, I have to divide the whole equation by sine theta. So now I will be getting dy over d theta plus y divided by sine theta. So instead of writing divided by sine theta, I will write times 1 over sine theta. That equals to tangent half theta divided by sine theta on the right side. And let this be the first equation. And then now, my integrating factor, it will be exponential of integration for 1 over sine theta. Okay, 1 over sine theta is the cosine theta. That's why you are given this result. So it is E ln tangent half theta. So the E and ln can be cancelled off because of this formula. E ln A is A. Alright, that means I'm getting tangent half theta for my I, integrating factor. I let this be second equation. Now I will write second equation multiplied to first equation. The left hand side by default it will be d over d theta yi. Okay, now for the right hand side I need to simplify. I need to multiply. So existing tangent half theta over sine theta. Now you need to times with tangent half theta. Okay, so now because you have half theta and sine 1 theta, so the sine 1 theta is like the multiple, is like the double of the half theta already. Therefore, I have to refer to sine 2a, double angle formula, which is 2 sine a cos a. Then now, my 2a is theta, which means the a is half theta. Okay, so I will replace my a by half theta on the right hand side. Then I will be getting okay, so from here you can change the tangent to sine and cos. At the same time you change it to sine and cos, so it will be sine, this is tangent squared, right? Tangent squared I will change to sine squared half theta over cos squared half theta, because this is tangent squared. And then this over sine theta, I will use this sine 2a. It will be 1 over, because you divide by sine theta is same as you times by 1 over sine theta. Then here I will get 2 sine half theta. Okay, here is and cos half theta. Okay, now from here I will simplify. So sine half theta cancel degree 1. Then I will be getting sine half theta over 2 cos degree 3 half theta. Alright, so for this, later on when we need to integrate, we have two methods, right? So y tangent half theta equals to integration of sine half theta over 2 cos cube theta over 2 d theta. Now for this integration, you can solve using two methods. Right, here I show you both methods. The first one is using substitution from here. That means your u is cos half theta. So then du over d theta equals to negative half sine 2 theta. Then my du, because here I have the half. Look at here. I have the half here. And then d theta. And then this is a sine. So it means that I keep this. Alright. So this is not 2 theta, half theta, because your u is cos half theta, so half theta. Alright, so now I will write du, or negative du, is half sine half theta d theta, so that I can combine all these three terms and I change to negative du. So now my y tangent half theta is same as negative integrate du, then left the cos cube half theta in the denominator. I will get 1 over u cube. Okay, so then here when you integrate, it will be u power negative 3. So when you integrate u power negative 3, this is u power negative 2 over negative 2, then after that plus c. Okay, so now minus minus is a plus. I will change to 1 over u squared plus c. And then look at the question here. You are given y and theta, and then final answer is the y. Therefore now I have to change back my u. So my u is basically cosine. Is cos. So I will get 1 over cos squared theta over 2 plus c. Okay, I leave it in this form first, and then I need to find the c before I simplify. So now my y is 1, theta is half pi. So y is 1, theta is half pi. That means now 1 tangent half times half pi means pi over 4 equals to 1 over cos half pi is pi over 4. Then you square it and plus c. So tangent pi over 4 is 1. Okay, the cos pi over 4 is basically 1 over square root 2. Then you square it. So for the right hand side, the first term becomes, okay, wait, let me check first. Okay, I miss out one term. You see here, there's a 2 here. Right, I move down the u squared. I still have the 2, so I miss out the 2 here. So there's a 2. This a 2, this a 2, this a 2, this a 2. Okay, so for the first term on the right hand side, square of 1 over square root x square root 2 is basically half. Therefore, for the right hand side, first term is 1. So obviously your c is 0. So once I get c is 0, okay, now remember we need to get the y. So this tangent move down, right? I will get y equals to this 1 over 2 cosec squared, right? You can just cos square theta over 2, sorry, cos square. So I will remain, and then the tangent I move down. Tangent I move down, it becomes 1 over tangent. So we know that tangent theta is sine theta over cos theta. So if 1 over tangent means it's cos theta over sine theta right now. So I will write cos half pi over sine half pi. So now to get the simplest form, the cos will be cancelled off here. Then I get 2 cos sine. 2 cos sine is basically sine 1 theta. Okay, so 1 over sine theta is basically cosec. So this is your final answer if you use this method. Right? And as I've mentioned to you just now, we have 2 methods for this integration. So now I'm going to show you the second method, how to integrate. So this is all. Right? Now my y, tangent half pi, half theta, equals to integration of sine half theta over 2. This cos cube I split into 2. Cos half theta and then another cos squared half theta here. Now this is half, right? Integrate half. This is tangent half theta, and then 1 over cos squared is secant squared. Then from here you can use u equals to tangent half theta. That means your du over d theta is going to be half secant square half theta. So now here I get half secant square half theta, right? Then together with the d theta means that now I will get my du is half secant square half theta d theta. So I will change all these 3 terms to be to get du. So it means that now y tangent half theta is integrate. Tangent half theta is my u. So I will just reduce to this simple integration. Then at last, I times back. So it will be half. The u will be changed to tangent theta over 2. But now it's squared. Okay, I'm getting this now. And then you replace the y values. So the y and theta. So your y is 1, theta is half pi. That means for the left hand side, it will be the same. Okay, it will be the same. So I will write tangent pi over 4 equals to half this tangent pi over 4 squared plus c. So it means 1 equals to half plus c. Therefore, my c is half. Okay, so then substitute back into this expression. Y tangent half theta equals to half tangent squared half theta plus half. Then now the half can be taken out. Okay, so this is 1 plus tangent squared theta over 2. Then at last your y So just divide by tangent, half theta. Then it will be half of 1 divided by tangent is cot half theta. Then tangent squared divided by tangent, it will be just tangent half theta. So you are getting different form of the final answer if you use two different methods. Okay. Now for question number 5. State the sum of the series for z not equals to 1. So now z plus z squared plus z cubed until z degree n. This is basically the geometric progression, which is the Sn equals to a bracket Rn minus 1 over R minus 1, whereby your a is z, your R is z squared over z, which is also z. Okay, so from here I will say this is same as a is z, R is also z, so z power n, because there are n terms here, degree 1 until degree n, then minus 1 over z minus 1. So that's the solution. Otherwise, you can just times in. So when I times in, it will be z of n plus 1, z with power of n plus 1, minus z over z minus 1. So that's all for this A. So for the B, given that z is the nth root of unity, unity means 1. Okay, and the z is not equal to 1, deduce that this sum, this sum equals to 0. So now Zn is 1. That's the meaning of n root of unity. Okay, then from here I know that from A, z plus z squared plus z cubed until Zn is this result. Okay, and now it's mentioned that z degree n is 1. So I will replace this by 1. Right. So now, before that, before this, I will have to write, it will be z plus z squared plus z cubed plus until the term before the zn is z power n minus 1, then plus 1. Okay, so here I better write one more term. So plus zn minus 1 plus z equals to this. This is n. And then this is 1. Right, from n root of unity. Then from here, Zn equals to 1. Alright, so for the right hand side, I get 1 minus 1 over z minus 1, which means now my right hand side is 0. Okay, so just rewrite all the terms on the left hand side. Now you need to prove this. So just move the 1, just move the last term to the front. Okay, move it to the front, then you will be getting exactly the same terms. So 1 plus z squared plus z cubed until z of n minus 1 will be 0. Okay? Oh, just like this. Now, part C, given instead that the z is 1 over 3 times cos theta plus I sin theta, use the De Moivre's theorem to show this sum. Alright, so now I will rewrite my z first. It's 1 over 3 cos theta plus I sin theta. This is same as 3 power negative 1. I make it to power negative 1 because here you have 3 power negative n. So 3 power negative 1 cos theta plus I sin theta. Now, if you need to get this, see, 3 power negative m, that means you have to consider power m for both. So z power m, it will be 3 power negative 1 cos theta plus I sine theta to the power of m. Okay, and based on the De Mor's theorem, this power m, okay, or just normal expansion first, will be moved into the bracket and multiply with 3 power negative 1 and also into the brackets here, the cos theta plus I sine theta. So for the cos theta plus I sine theta, based on the De Mor's theorem, the m will be multiplied to the theta. Therefore, here is going to be 3 power negative m, then cos m theta plus I sine m theta according to the De Mor's theorem. Okay, and now you see I already found the m theta here, cos m theta, and together with the 3, but I still have the I sine. Therefore now I will have to decide. I have to refer to the summation of z degree m. Then later I will just take the real part because I don't want the sine. Okay, so now summation m from 1, okay, just follow this, m from 1 to infinity, and then the z degree m, it will be, okay, when you replace the m by 1 now, so the z degree m means that it is z degree 1. Okay, then because of the sum, it is plus, then when the n is next value, which is z squared, okay, plus z cubed until infinity. Then this is same as GP, right? Geometric progression, which is s infinity, sum to infinity. This is a geometric series. So s infinity is a over 1 minus r. Again, the a is z, the r is z. So from here, I will say this is same as z over 1 minus z. Okay, then now I will just replace the z degree m by this expression. So left hand side becomes summation m from 1 to infinity 3 power negative m cos m theta plus I sine m theta. Okay, then this is z. So it means it is same as the z here is replaced by this expression 1 over 3 cos theta plus I sine theta. Okay, is to be replaced here. So now I will get 1 over 3 cos theta plus I sine theta over 1 minus z. So 1 minus 1 over 3 cos theta plus I sine theta. Okay, so now I get the same denominator first. So 1 over 3 cos theta plus I sine theta. Now here I take out the 1 over 3. So when I factorize the 1 over 3, I get 3 minus cos theta. The minus move in, minus I sine theta. Alright, so from here, the 1 over 3 will be cancelled off from numerator and denominator. Therefore, I will be getting the division of two complex numbers. And my real parts for the denominator is 3 minus cos theta. Right. So now from here, when you look at the answer, I need this. Right, and we just consider cos. Therefore, later I need to consider the real parts of this result. What I need to do now is I need to rationalize the denominator. So, alright, so I will continue over here. Summation m equals to 1 to infinity 3 power minus m cos m theta plus I sine m theta. Okay, so equals to cos theta plus I sine theta over, here I need to do expansion. Okay, I need more space. Equals to cos theta plus I sine theta over, this one I copy from here, 3 minus cos theta minus I sine theta. So to rationalize the complex number in the denominator, we just times the conjugate. Right? Conjugates means the real parts you change to opposite sign. Means the minus change to plus, the plus change to minus. So I will have to times by 3 minus cos theta plus I sine theta over 3 minus cos theta, then plus I sine theta. Okay, now I need to do expansion. So for your information, for the denominator, this is A, this is B, here is A, is B, A minus B times A plus B, right, for the complex number, or I would say conjugate. Okay, so complex number times by its conjugate, it will be, let's say your complex number is A plus BI. So it will be A squared plus B squared. Okay, therefore, I will just use this shortcut to simplify the denominator. Then I will be getting 3 minus cos theta squared plus sine squared. Okay, but then for the numerator, we have no choice, must expand one by one. So now, cos theta multiplied with 3 minus cos theta, you will get 3 cos theta minus cos squared theta. Then cos theta times plus I sine theta is plus I cos theta sine theta. And then the next expansion is the imaginary part. So times I sine theta to the 3. So I get plus 3 sine theta I sine theta times minus cos theta, it will be minus sine theta cos theta I. Okay, lastly, I sine theta multiplied with I sine theta, it will be I squared, positive I squared sine theta. So then I squared is minus 1. Therefore, I will just direct change it to minus sine squared theta. Okay, so now simplify all the terms. Now for denominator, expand using quadratic expansion. It will be 9 minus 6 cos theta plus cos squared theta. And then the right hand side, I mean the second term, it will be sine squared theta. So for the numerator, alright, I will group all the real and imaginary parts. So my real parts will be 3 cos theta minus cos squared, and then minus sine squared. So here I will get 3 minus cos squared theta minus sine squared theta. I will write minus of cos squared theta plus sine squared theta. This is my real part. Okay, so for imaginary part, you will notice that these two terms can be cancelled off because 1 plus 1 minus just left the 3 sine theta I. And then now I can further simplify. My cos squared theta plus sine squared theta is 1. Therefore, this will be changed to 1. Okay, and then I will get 3 minus 1. Wait, I missed out. This is 3 cos theta. I just wrote 3. It should have a 3. It should have cos theta there. Alright, so sorry for that. Alright, so here, this is cos theta minus. So for the next one, I have to write 3 cos theta minus 1. Then over, I split into real and imaginary parts now. These two will be 1. Okay, cos squared plus sin squared is 1. So 9 plus 1, it will be 10. So I get 10 minus 6 cos theta. Then plus 3 sin theta over 10 minus 6 cos theta. And this is the I. So now I'm getting real and imaginary part. When you refer back to the question, we just need the cos. Right here, just cos. That means this is the real part of my expression, because here I have cos and sine. So now I will just need to consider the real part of sum to infinity. Okay, this will be just this real part. So it will be 3 cos theta minus 1 over 10 minus 6 cos theta. And now let's check the answer. Alright, so I get 3 cos theta minus 1 over 10 minus 6 cos theta. Okay, so shown. Alright, this is the solution for this question. Okay, now question 6. The matrix A is given by this. Find the matrix P and D such that A square is PDP inverse. So now here we need to get the eigenvalues and eigenvectors before we get the matrix P and D. Alright, so first of all, I have to refer to the characteristic equation. Determinant of A minus lambda I equals to 0. So all the diagonal values must be minus lambda. So I get 5 minus lambda, 0, 0. Negative 22 over 3 minus 6 minus lambda, 0. 8, 0, 1 minus lambda. That equals to 0. So from here, I will fix the first column. Okay, because there are two zeros. Then the sign for the first value is plus. Then when I consider the first row, okay, the cross up is 5 minus lambda. So then the remaining elements just copy and change to determinant. Then from here, obviously, right, you will get 5 minus lambda times minus 6 minus lambda times 1 minus lambda equals to 0. Therefore, when you let all these brackets be 0, I will get lambda equals to 5 from the first bracket. Second bracket is minus 6. Third bracket is 1. So I found 3 eigenvalues. Now, from the eigenvalues, we need to get eigenvectors. So when lambda equals to 5, you can use solving simultaneous equations to find the eigenvectors, or you just use cross product. Okay, so here I will be using the solving of equations. So now substitute this lambda equals to 5 into this equation, into this matrix, right? Change the straight lines into brackets. So you will be getting 0, 0, 0, negative 22 over 3. So when lambda is 5, so minus 6 minus 5 is minus 11. Then here will be 0, 8, 0. And the last value, when you replace this lambda by 5, 1 minus 5 is minus 4. Okay, so here I get minus 4. And you multiply with 3 variables and equals to all 0. So from here, when I refer to last equation, okay, or second equation, so minus 11y when you do expansion, right? This multiply with this, you will only get the y equals to 0. That means the y is 0. And refer to the last row. So I will get minus 4, z is 0. Therefore, the z is 0. Then now, you will never get the x because the x is always 0. The coefficient for x always 0. So it means your x can be any value, right? So I let it be t. Therefore, my result is x equals to t. y is 0, the z is 0. So now take out the t, it will be 1, 0, 0. Okay, then I get my lambda 1 is 5. My E1 is 1, 0, 0. So this is the working by solving simultaneous equations. Otherwise, you can just use the vector product. Now, I need to solve for lambda equals to minus 6 and 1. Okay, so I better show it here side by side. Lambda equals to minus 6, right? So we substitute into here. 5 minus minus 6 is 11. Then for the next value, minus 6 minus minus 6 is 0. Lastly, when the lambda here is minus 6, so 1 minus minus 6, you get 7. Now, for the last row, when I do the expansion here, the multiplication, so when you multiply, you will get 7z equals to 0. That means your z is 0. Okay, the second row here, you get all 0. Then now I have to refer to first equation. So 11x minus 22 over 3y. Since the z already found, which is 0, so 8 0, 8 times z, well, no need to consider anymore. I will just let it be 0. So from here, 11x is 22 over 3y. Then I can just divide the whole equation by x. So now my divide the whole equation by 11. So now my x is going to be 2 over 3 y. So now my x depends on y. I will just let the y be, let's say, s. Therefore, my x is 2 over 3s. Okay, and then I will write down my solution first. So it will be 2 over 3s for the x. The y is 1s. The z is 0. From here, I can factorize 1 over 3s. So the first term becomes 2. The second term, when you factorize 1 over 3s from s, that means you are getting you are getting 3. Then here is 0. So from here, I will say lambda 2 is minus 6. Then the E2 will be 230. Okay, and now for lambda 3 equals to last value 1. So repeat the same steps. I will get a matrix. So when now lambda is 1, when you substitute into this, right? So 5 minus 1 is 4. So I will get 400. And then negative 22 over 3. We need to count the middle value. So now your lambda is 1. So minus 6 minus 1 becomes minus 7. I'll get minus 7 and 0. Then 8, 0. Now lastly, when your lambda is 1, so 1 minus 1 is 0. Okay, so obviously when you refer to the second row, I will get minus 7y is 0. Hence my y is 0. Now last row, all 0, no need to consider. Now consider the first row. So I will get 4x minus 20. Okay, 22 over 3, you multiply by y. It will be 0 because the y is already 0. So I will just skip that and consider the 8z. Okay, so from here, my x is minus 2z. Now for this case, I will let my z be u. That means my x is going to be minus 2u. So now I will rewrite my solution. So my x is minus 2u, my y is 0, my z is u. Therefore, the u can be taken out and you get negative 2, 0, 1. Okay, so my third lambda is 1 and the corresponding eigenvector will be negative 2, 0, 1. Or you can just write 2, 0, minus 1, also no problem. Okay, once you have found this, let's look at the question. So this is a squared equals to PDP inverse. So now our D is the square of the matrix, which consists of all the diagonal, all the eigenvalues. Okay, so now A square is PD P inverse. That means now your D, first eigenvalue 5, second eigenvalue minus 6, and third is 1. So I will write 5, 0, 0, 0 minus 6, 0, 0, 0, 1. But then I have to square it because of the A squared here. Right? So now the answer for this is 5 squared, 0, 0, 0, then negative 6 squared. You just need to square all the eigenvalues. Then you will be getting 25, 0, 0, 0, 36, 0, 0, 0, 1. That is your D, matrix D. Together with the P, it will be the corresponding eigenvectors. So the first one, 1, 0, 0, then 2, 3, 0, and the last one, negative 2, 0, 1. So just put all of this into the matrix, but it will be the columns of the matrix P. Okay, so that's all for the D and P. Now, B, use a characteristic equation of A to find A cubed. So for the characteristic equation, right, we have to refer to this step. Okay, and we have to do the expansion. So I will write down first 5 minus lambda minus 6 minus lambda and 1 minus lambda equals to 0. So from here we do the expansion to get the polynomial. So I expand the last two brackets, okay, or last two factors. So when you do expansion, you get minus 6 plus 6 lambda minus lambda plus lambda squared equals to 0. Then this can be simplified into lambda squared plus 5 lambda minus 6 equals to 0. And now further expand. Alright, so then you will be getting 5 lambda squared plus 25 lambda minus 30, and then minus lambda multiplied to the whole bracket. It will be minus lambda cubed minus 5 lambda squared plus 6 lambda equals to 0. Then now, when you simplify the terms, right, the lambda square will be cancelled off. Okay, then the 25 lambda here will be added with the 6 lambda, becomes 31 lambda together with minus 30 equals to 0. So now we need to find A cubed. Okay, so here I will get the positive values first. Means I move all the terms to right side. So it means that lambda cubed minus 31 lambda. Or I need to get the the lambda cube as a subject also doesn't matter. So it means that I will just move this to the right side. Okay, the rest keep. So it will be minus 30 here. So now this is our characteristic equation. But now you need to get characteristic equation of A, which means now you replace the lambda by A. So I will get A cubed equals to 31A minus, now lambda is a constant, which is the eigenvalue. And then we need to get the A is a matrix. So from the 30, you change to 30I. I is the identity matrix. Okay, and now we need to find A cubed. This is just an expression. So now your A cubed will be 31 times the matrix A. So copy the matrix A from the previous part. Okay. So here I will get 500 minus 22 over 3 minus 60, 801. That is my A. Then minus 30I. I is the identity matrix. Right. So from here, when I times in and minus, right, then you will be getting 125 0, 0, minus 6, 8, 2 over 3, minus 216, then 0, 2, 4, 8, 0, and 1. So this is our A cube matrix. Okay, so now question 7 is given that y equals to inverse of hyperbolic second x plus half. This is the expression for the y. Express cos y in terms of x and hence show this differentiation. So when y equals to inverse hyperbolic second of x plus 1 over 2, alright, so before I proceed, because now you need to get cos, right? So we know that cos y is 1 over hyperbolic second y. So I need to eliminate this inverse. So the inverse move to the other side becomes hyperbolic second y equals to x plus half. Okay, to eliminate the inverse. So just move the hyperbolic second to the left hand side. Then now I will change the hyperbolic second y to cos y equals to x plus half. So in order to get cos y, this cos y move up, the x plus half move down. So this is my expression for cos y. Now enhance means use this expression to show the differentiation. So now, before I differentiate, I will write cos y is x plus half to the power of negative 1. Okay, so I will differentiate based on this expression. So now, differentiate cos y, it is sin y dy over dx. And then we differentiate degree of negative 1 for x plus half, bring down the negative 1, rewrite the function. We are using the power rule now. Okay, then power negative 2 and differentiate x plus half is 1. So this is the power rule. Differentiate fx to the power of n. It will be n fx to the power of n minus 1 times f prime x. So now, let's check this form. So left hand side already found the terms. Okay, right hand side I just need to move down the power negative 2. Alright, so it will be negative 1 over x plus half squared. So with this, I have shown the expression. Now for B, find the first three terms in Maclaurin series of this expression, which is our y, in the form of ln A plus bx plus cx squared, where A, B, C are constants to be determined. So now, you need to find this is actually the y. Okay, so now I will write y equals to inverse hyperbolic second x plus half. So first of all, we need to count what is the y value when the x equals to 0. So now here, okay, when the x equals to 0, my y is inverse hyperbolic x, x is 0, so half. But then we look at the answer here. It will be in terms of ln and in terms of ln, okay, I will say in terms of ln. Now, to get inverse hyperbolic second half in terms of ln, we need to use this concept. Okay, so from A, alright, from first part, because we don't have the formula for inverse hyperbolic x in the formula list. You are just given inverse hyperbolic cos x. Alright, so I need to get the relationship between inverse hyperbolic second x and the inverse hyperbolic cos x. So now, we know that y equals to inverse hyperbolic x second x plus half. So I let u be x plus half, then it will be simpler form. That means your y is inverse hyperbolic second u. Okay, then now from here we know that, okay, from this step I can jump to this step, right? Y equals to inverse hyperbolic x plus half. X plus half is my u now. It becomes cos y equals to 1 over u based on this. So I will write cos y equals to 1 over u. Okay, therefore from here my y is inverse cos 1 over u. But then when you refer to these two forms, okay, both also y, which means I get an important result. Hyperbolic second u equals to inverse hyperbolic second u is inverse hyperbolic cos 1 over u. Okay, therefore here I will write this is inverse hyperbolic cos 1 over half. So 1 over half is basically 2. Okay, based on this. And then now from the formula list, you are given inverse hyperbolic cos or inverse hyperbolic cos x is ln of x plus square root of x squared minus 1, whereby the x is at least 1. Okay, so by referring to this expression in the formula list, now my x is 2. Okay, that means I can use this formula and get my answer in ln. So it will be ln of x is 2 plus square root of 2 square minus 1, which means you'll be getting 2 plus square 2 square is 4, 4 minus 1 is 3, so it will be square root 3. This is my y value when x goes to 0. Okay, and then now for the Fourier series, since you need to get x squared, means that we need to differentiate up to second derivative. Just now we have found the first derivative, which is this result. So now I'm going to copy this and replace the x by 0. Okay, so I will get sine y. So from a sine y dy dx equals to negative 1 over x plus half squared. So when x equals to 0, right? So sine y, I already found my y just now. So look at here. When x is 0, this is my y. Right? So I'm going to replace here. So it will be ln of 2 plus square root 3. That is my y. Then dy dx. And for the right side, your x is 0. So negative 1 over 0 plus half is half. So half squared. Alright. So now, I will be getting right side 1 over 4. So negative 4. This is my value. But then I need to find out what is my sign of the ln. Okay. So I will rewrite first. For your information, sine x is half of ex minus e negative x. So now this is my x. Okay, I will be getting half of exponential ln 2 plus square root 3 minus e negative ln 2 plus square root 3 dy dx equals to negative 4. Okay, then now from here, basically we have another formula. E ln A is A. So these two can be cancelled off, right? But the e negative you have to bring up first. E, let's say I will say a ln b is ln b power a. So this negative will be brought up and becomes the degree of 2 plus square root 3. Then the e and ln can be cancelled off. So with this, I will get half. This is 2 plus square root 3 minus, okay, degree negative 1. So 2 plus square root 3 degree negative 1 dy dx equals to negative 4. Right? Then now, when you simplify, so I will get half 2 plus square root 3 minus 1 over 2 plus square root 3 dy dx equals to negative 4. So now get the same denominator, or probably you can just get the times a conjugate or rationalize the square root. So I times 2 minus square root 3, then over 2 plus square root 3 and times with 2 minus square root 3. Okay, and then now here I will get half 2 plus square root 3. So use the formula a minus b times a plus b is a squared minus b squared for the denominator. Then I will be getting 2 minus root 3 over 2 squared minus root 3 squared. Okay, so now 2 squared minus root 3 squared. Minus root 3 squared means it is minus 3. So 2 squared minus 3 is 4 minus 3, which is 1. So which means I will be getting 2 plus root 3 minus this minus times in, so minus 2 plus root 3. Okay, so we have opened all the brackets. So now the 2 will be cancelled off. So root 3 is 2 root 3. The 2 root 3 and the half outside. If you want to do step by step, this will be the working. Then now the half and 2 cancel off. Root 3 dy dx is negative 4. Therefore, my dy dx is negative 4 over root 3 at x equals to 0. Okay, now this is not enough. We need to get one more term because your expansion is up to x squared. So now, one more term means that we need to differentiate. So now I will have to differentiate this form. Okay, so I will move up the denominator first and rewrite the rest. So now I will write sin y dy dx equals to negative of x plus half to the power of negative 2. And now I differentiate. So to differentiate, this is uv, products rule. So differentiate using products rule, it will be uv prime plus vu prime. Okay, so then I keep the sin y, differentiate dy dx, it will be d squared y over dx squared. Then plus, keep the dy dx, differentiate sin y with respect to x. So this one you need to be careful. Differentiate sin y with respect to x, different variables. So we need to differentiate the sin y with respect to y first, because it will be the same variable. Then you multiply by dy dx. This is the chain rule. Okay, so this is how we differentiate the function of y with respect to x. So now I will get differentiate sin y is cos y, then multiply with dy over dx. Please take note on this. Now for the right hand side, bring down the negative 2, it becomes positive 2. Keep the bracket, then always minus 1 from the existing degree becomes minus 3, and differentiate x plus half, it will be 1. Okay, so from here I can find the value. We know that when x equals to 0, okay, we need to get what is the sine y, what is the cos y. Just now we have found the sine y. Okay, here. We have found the sine y. Where is the sine y? Okay, for your information, look at this. Look at this. This is sine y. Okay, so it means all these terms will be the sine y. And then at last, I'm getting this, isn't it? This is square root 3 dy dx. Means the coefficient for the dy dx on the left hand side will be the sine y. So now I will write down the result first. So when x equals to 0, my sine y is square root 3. And then my dy dx equals to negative 4 over square root 3. But now I need to get what is my cos y. Okay, so use the same concept by referring to the definition. So cos y is half of just now the y. Okay, I will say is cos my y in terms of ln in the beginning. So my y is ln of 2 plus square root 3. So ln of 2 plus square root 3. So the cos definition is half of ex plus e minus x. Just now minus, now plus. Okay, so we can use the result from the sine basically. We can just modify. So half of e ln 2 plus square root 3 plus e negative ln 2 plus square root 3. Now here becomes half of 2 plus square root 3 plus 1 over 2 plus square root 3. Okay, and then for these two parts, right, for all this, the difference now is the plus when you compare to this expression. Just now was minus. So what I need to do is I will just change this minus to plus. I will just change, okay, I just change to plus, and then when I change to plus, this one will be plus, this one will be minus. Alright, so I will direct jump to this step now. So 2 plus root 3 plus 2 minus square root 3. It will be half 2 plus root 3 plus 2 minus square root 3. So obviously the 2 plus 2 will be 4. 4 divided by half, it will be 2. Okay, the square root 3 will be cancelled off. These two cancel off. Now, I found my cos y. Then you can just substitute into this expression and let the x be 0. So x equals to 0. Sine y is square root 3. Then second derivative plus dy dx is minus 4 over square root 3 from here. Then the cos y is 2 and another dy dx. That equals to 2 bracket. So when x is 0, you get half to the power of negative 3. Then now here, I will get square root 3 second derivative. Then for the second term, right, minus 4 over square root 3, you square it, it will be 16 over 3. Then you times another 2, it will be 32 over 3. Then for the right hand side, when you simplify, it will be 16. Okay, now your d squared y over dx squared, it is 1 over square root 3 times 16 minus 32 over 3. Okay, at last you will get 16 over 3 root 3. Now once you have found this, then we can form the Maclaurin series. So Maclaurin series of y. So now I will write y equals to So when x goes to 0, my y is ln 2 plus square root 3. So the formula for Maclaurin series is basically y0 plus x dy dx 0, okay, or I write y prime 0 plus x squared over 2 factorial y double prime 0. So now here I will write ln of 2 plus square root 3 plus x times the dy dx. So the dy dx is negative 4 over square root 3. Then here, x squared over 2 factorial is 2. Then the y double prime, I get this, 16 over 3 square root 3. So now final answer, just simplify all the terms. Then here minus 4 over square root 3x. And then lastly, it will be 8 over 3 square root 3x squared. So this is your Maclaurin series. Alright, that's why when you refer to here, it will be exactly the same. Okay, so with this, we have completed question 7. Now, next question number 8. Given x is 2 cos t, y is this, where t defined from 0 to 1, find dx dt and show dy dt. So, x is 2 cos t, dx dt, differentiate cos is sine. Alright, so y is 3 over 2t minus 1 over 4 sine 2t. And then to show this. Oops. So now dy over dt, when you differentiate, I get 3 over 2. Keep the negative 1 over 4. This is sine 2t, right? Let me write properly. This is 2. So when you differentiate sine 2t, you will get cos 2t, and differentiate 2t is 2. So from here, right, my dy over dt is 3 over 2 minus 2 over 4 is half. So I will get half cos 2t. But then when you look at the answer, it is in terms of sine squared. So what I need to do here is I factorize the half first. I'll get 3 minus cos 2t. And then now I need to refer to the double angle formula in cos. Right? So now cos 2t is cos squared t plus sine squared t from the formula list. Okay, and now I need to get sine squared. I don't want cos. So use another formula, another identity. Cos squared t minus sine squared t is 1. So it means that cos squared t is 1 plus sine squared t. And now you substitute into this. So therefore, cos 2t is 1 plus sine squared t plus another sine squared t. Therefore, it is 1 plus 2 sine squared t. Okay, this is the expression that we are using. So now, I will get half 3 minus, it will be 1 plus 2 sine squared t. So here half, open the bracket, 3 minus 1 minus 2 sine squared t. So I will get half of 3 minus 1 is 2. Okay, so factorize the 2, it will be 1 minus sine squared t. That is our dy over dt. Okay, now, next part is the area of the surface generated when C is rotated through 2 pi radians about the x-axis, right? Area of surface generated and through about is rotated about the x-axis is denoted by A. B, first part, show that A equals to this form. Okay, our formula for the surface area is 2 pi integrate 0 to 1 y square root of dx dt squared plus dy over dt squared dt. Okay, just now we have found the dx dt. See here, dx dt, dy dt. dy dt is this form. So now I will get my dx dt squared plus dy dt squared first before I substitute into this A formula. So my dx dt is 2 sine t, and this is my dy dt. So I will just direct replace now. It will be 2 sine t squared plus 1 minus sine squared t. Then you square. Okay, now when do expansion, first term is 4 sine squared t. Then for the second term, use a quadratic expansion. It will be 1 minus 2 sine squared t plus sine degree 4t. So when you simplify, it will be sine degree 4t. So the 4 sine squared t minus 2 sine squared t will be plus 2 sine squared t, then plus 1. And here, because of the square root in the formula, I will change to square of a term, okay, or square of 2 terms. So it's basically square of sine squared t plus 1. Alright? Then this can be further simplified because we know that 1 plus sine squared t from the previous step, it will be cos squared t. So I will change this to cos squared t. Alright, so now my A is 2 pi integrate 0 to 1. The y, okay, replace the y now. The y is these 2 terms. So I will write 3 over 2 t minus 1 over 4 sine 2t, that is my y, square root of cos squared t and another squared outside. So now the square and square root can be cancelled off. Okay, then I will be getting, now let's check the answer first. Okay, you need to get 1 plus cos 2t. So the y no change, and then there's a pi outside. So it means that my steps here, the 2 must be brought in. Okay, so the rest simplify, and I need to keep the y. So after you cancel the square and square root, it's basically cos squared t. And there's a 2 there, okay? I forgot the 2. So I need to add on the 2. Alright, and now let's look at the answer. We need cos 2t. Okay, cos 2t is here. And right now I have 2 cos squared t. So use the formula. Right, cos 2t equals to cos squared t plus sine squared t. So for the sine squared, I will change. Okay, look at here. Sine squared, I move to the right side to get positive. Then the 1 will be moved to the left side to get negative. So it will be cos squared t minus 1. So sine squared t is cos squared t minus 1. Therefore, my cos 2t is cos squared t plus another cos squared t minus 1. end up with 2 cos squared t minus 1. Okay, so now here I get 2 cos squared t. Then I just need to keep this term on the right side and the minus 1 move to right side move to the left side. So I will get 1 plus cos 2t. So here you will get 1 plus cos 2t dt. Okay, so let's check the answer. Exactly the same from now. So this is how I prove the expression for A. Okay, now part 2. Hence, find the A in terms of pi, sine 2, and cos 2. Means that now we need to integrate this. Okay, I will rewrite this expression in the next part. So now my A is pi integrate 0 to 1, 3 over 2t minus 1 over 4 sine 2t multiply with 1 plus cos 2t dt. Okay, for this, I will split it into 2 integrations. So, the first integration is 3 over 2t multiply with the next bracket. Second integration will be negative 1 over 4 sine 2t multiply with the next bracket. So these are my 2 integrations. So now for the second term, okay, or second integration, since there's a 1 over 4 here, I will combine with the pi. And I will take it out. It becomes negative 1 over 4 pi integrate 0 to 1. Then sine 2t, then multiply with 1 plus cos 2t dt. Okay, so the purpose I split it into 2 integrations is because of the first integration I'm going to use by parts. The second integration I'm going to apply substitution method. Okay, so now for the first integration, my u is 3 over 2t, and then my u prime is 3 over 2. So v prime is 1 plus cos 2t. So then the v is integration. So integration of 1 plus cos 2t, the integration of 1 is t. Integrate cos is sine, then 2t over 2. So for the second integration, I'm going to use the substitution. My u is 1 plus cos 2t. So du over dt is 2 sine 2t. So when you look at the integration here, sine 2t dt. Alright, so I will combine. This dt move up, the 2 move down. So I will get half du is sine 2t dt. Then now, don't forget to calculate the u values. Okay, when t equals to 0, here, the u is 1 plus cos 0, which is 2. When t equals to 1, my u is 1 plus cos 2. Okay, after I have written down all this, then I can start doing the integration. So now my a is first term pi. So when you use integration by parts, integrate uv prime dt equals to uv minus v du dx, vu prime dt. Okay, with limits ab, so you just count the limits. Alright, so this is the formula. So now I will write down uv, so just multiply. 0 to 1, put another bracket, minus integrate 0 to 1 v du. Okay, so 3 over 2 t plus sine 2t over 2. And then for the other one is negative 1 over 4 pi. Okay, integrate. So here I have to use substitution. Now limits 0 to 1 becomes 2 to 1 plus cos 2. So here I will write 2 to 1 plus cos 2. And then 1 plus cos 2u is 1 plus cos 2t is u, and then the rest will be half du. So I have another half du. Okay, this is my differentiation. This is my integration after the substitution. Integration, I mean the simplified integration form after my substitution. So now I will replace the t value by 1. So you will get 3 over 2, 1 plus sine 2 over 2, minus, when t is 0, everything is 0. Okay, and put another bracket. Then now minus, this 3 over 2 I take out. Integrate t will be t squared over 2. Then the sine 2t over 2 becomes cos 2t over 4. Okay, and now for the next integration, this half and 1 over 4 pi will be combined. So I get negative 1 over 8 pi. Left integration of u du. So integrate u squared over 2. And then the limits from 2 to 1 plus cos 2. Okay, so here simplify. I will do the expansion. 3 over 2 plus 3 over 4 sine 2. Okay, then minus 3 over 2. So replace the t by 1. I get 1 over 2 plus cos 2 over 4 minus when the t by 0. So the first one is 0, but the cos 0, right? Cos 0, you will get a value. So here is cos 0 over 4. Then the 2 here moved out. Negative 1 over 16 pi. Replace the u by 1 plus cos 2. So I will get 1 plus cos 2 squared minus 2 squared. Okay, so here I need to close bracket. Now I will get pi. Okay, so 3 over 2, open all the brackets, plus 3 over 4 sine 2 minus, this one times in, so 3 over 4 minus 3 over 8 cos 2. Okay, the 0 no need to calculate. The minus here times in, this is another minus, so minus minus is a plus. I will get 3 over 8, because here 4, here 2, cos 0 minus pi over 16, and I keep it in this form because the question says leave your answer in pi sine 2 cos 2. So I don't want to expand this. Right, I just keep it in this form. So it will be 1 plus cos 2 squared, and then this negative 1 over 16 pi times to the negative 4. Okay, minus 2 squared means minus 4. So minus minus is a plus. Therefore, you will be getting plus 4 over 16 pi, which is pi over 4. So now, when you simplify this, okay, look at the constants first. 3 over 2 minus 3 over 4. And then together with this, 3 over 8 cos 0. So then you will simplify it, and it will be 9/8. Because the cos 0 is 1. Okay, so when you simplify these three terms, you will get 9/8. So here I will get pi 9/8. Then copy the other two terms. These two terms, just rewrite. Okay. Then now minus pi/16. Copy the rest. And then next step is to simplify the answer. So from here, the pi can be taken out, which is in common. Then the rest, right? So here, once I've taken out, I will get 9/8 plus 3/4 sine 2 minus 3/8 cos 2. Minus, here I get 1/16, 1 plus cos 2 squared. When you factorize the pi, I get 1/4. So now, final answer, 9/8 and 1/4 can be combined. So it will be 11/8. And the rest of the terms just rewrite. And that will be our final answer. So you will write 3/4 sine 2 minus 3/8 cos 2 minus 1/16 times 1 plus cos 2 squared. So 9/8 plus 1/4, it will be 11/8. So this is your A. Alright, so we have come to the end of the video. Thank you for watching. Please subscribe to my channel if you enjoy watching my video. Right, and stay tuned for more upcoming videos. Thank you. Bye.